Today, Open Source Security is talking to Luke Hinds. He's a long-term open source wonk and the CEO of the startup Always Further. I've known Luke for a super long time. We were at Red Hat together. He's a marvelous person. And I actually had a listener, thank you, Bradbury, who sent me an email and said, hey, it'd be great if you could talk about MCP security. And I was like, I need to find someone who knows about like AI stuff and isn't a crazy person. And Luke, you're the top of my list, man. So welcome to the show.
Thank you for having me. It's great to be here, Josh. I've been a long-term fan of the show. Absolutely.
Awesome.
And, and thank you for the nice intro.
Yeah, no, this is going to be awesome. So let's start out, not so much on MCP security, but you have a brand new project that's kind of lit the world on fire. So tell us about your project and tell us about your company, because I think they're both doing interesting things in the world of open source.
Absolutely, yeah. So we put out a project called Nono. And when I say put out, we put it out by the seat of our pants. And it was not exactly polished, but, we did it for a good reason. The weekend saw a whole load of carnage around OpenClaw, which I'm sure everybody's heard of. If you haven't, it's effectively an AI project. It has a sort of a services component and some agents. And it can integrate with different services, WhatsApp, Telegram, Gmail. So you can connect all of these agents, and it's kind of like a personal organizer. And it had a lot of security teething problems. And okay, I got something that's useful. Let's give it a polish and put it out there. And needed to come up with a name. And I'm just awful at names. I hate naming projects. Whenever I get a good name, somebody's effectively squatting it somewhere. And then you've got to kind of go and beg to the package managers, please release it so I can have that name. But I came up with the name Nono, because kind of essentially the opposite of YOLO, you only live once. And,
Nice.
Which seems to be the kind of the rallying call of the vibe coders. And so we came up with Nono, and Nono was available on Rust crates, which was, actually, no, it wasn't, but somebody kindly handed it over to me. So it all just kind of slipped into place, really. And and so Nono is it's some code that uses kernel-based isolation, sandboxing of a process. So everybody knows you execute a piece of software. It's spawned as a process on an operating system, and so we have a kind of a layer of control around what it can access file-wise. Because with agents, we've seen all sorts of very familiar things happening to us security folks. Data exfiltration, access of files, secrets, destructive actions, deleting somebody's home directory. And then I thought this is classic process isolation, and deny by default. And so that's essentially what Nono does. We do a little bit more. Keys are protected. So if you've got like a Silicon Mac, you get the security enclave chip thrown in with keychains. So we kind of keep your API secrets in there. They're loaded safely and then scrambled at the end when the process exits. And just some protections around the old RF /home carnage. And the project's come out of a startup that I'm a co-founder of, Always Further. We're quite young. We've only been going for a couple of months, myself and my co-founder. And we're looking at lots of things around model security, agent security, and a lot of experimentation and a lot of fun. And we feel like we're starting to find some areas where we can alleviate some pains. It's always good to have a solution to a real problem, and there's clearly a problem out there. And but it's going to take a more than just one startup to fix this. Do you see what I mean? So, it's as always, it's going to be, it's going to be a concerted, wide effort, to patch up this one.
Yeah, for sure. I mean, so my favorite example right now I use is like Claude Code has a sandbox built into it. And I have a friend who was testing out how to, sandbox these processes because they didn't want, Claude Code running rm-rf on their home directory. And they turned on the Claude Code sandbox. And at one point it was working through what it's trying to do. And it says, oh, I see the sandbox is enabled. Let me turn that off and try again.
Yeah.
No!
I know. I saw the same thing. Yeah, very much, And it kind of makes sense because these models are heavily trained to reason around
Yeah.
any sort of thing that gets in their path that stops them achieving their goal. They're just repeatedly trained over and over and over to have that propensity to sidestep, to do anything to get to that goal. And, that's where it makes it a really interesting bedfellow to security.
Yeah. Yeah.
You know?
Okay. So I'm going to ask what I think is the obvious question for a lot of people
Mm.
is why should we use no instead of just like running in a Docker container or something like that?
Right. Yes. So I would start off with a Docker container provides really good levels of isolation. There's a little bit of fringe pros and cons to both technologies. Uh, with a container, obviously you're getting multiple processes that are namespaced. Okay, so you can get good protections around resource utilization. Okay, and of course the user namespace, the network namespace. So container security is very robust, and perhaps if you're doing something at scale, something like Kubernetes, it's a logical choice to make. I think the with what we're doing, it is very, very fast startup time. That's important, I think, for some people. We developed the thing in Rust, so it's very fast. So there's no lag within the UX or the start time. It is very quick and easy for people to get going with. Okay, so it's simply just
Yeah.
one command, and you literally drop the name of the agent onto the end of it. And yeah, I mean, but both have got really good attributes. So this wasn't in any way way of sort of trying to address a gap that containers had left. It's and I think you can go belt and braces. Effectively, you could use no within a container. Very much, yeah. And the
Nice.
other thing with no, of course, is you get batched in extra things such as there's some features outside of the isolation as well. We're able to we have certain commands which are no, DD, RM, etc. Sort of things that you really don't want an agent to run. And there's the kind of the key protection. And we're also looking at things such as sort of time-based allocation of commands and undo, because the old thing
Oh,
of the kind of the agent decides I'm just going to delete the database and start again. This sort of stuff. So yeah, we're able to introduce just a bit more, but this wasn't really a way of trying to balance up any gaps that containers have. I know container security's come a really long way, and it's very well battle tested. So
yeah. Yeah. Well,
mm,
I mean, I'll tell you what my first impression was here, Luke, is
mm,
just I know a lot of people toying with a lot of this technology that they don't understand necessarily how containers work. And what happens is they try to do something in a container and they might not be able to figure it out. Because let's face it, like making containers work correctly is a weird skill. Like it's a pretty
mm,
high cliff you have to climb to get that initial skill set. And what happens is they want to do something right now. And they're like, screw it, I'll just do it on my desktop anyway. And so I think that's the big sell to no is
yeah,
it's simple, right? It's
very
so
easy.
easy.
Yeah, very much. Yeah, very much. There is no volumes to mount. There's no networking to set up. Stuff that that we are comfortable doing from years of working with the technology.
Right.
But as you say, people are new to this space. And I think we have to be honest with ourselves. A software developer has changed. Really, anybody can generate code now. Everybody is generating code. I've not got Mrs. Hinds to do any vibe coding, but I'm pretty sure she could knock something up, and these people haven't got this prior art, this prior experience. And so, yeah, so that's where no's good. It is, like you say, it's very simple to use, as long as you can install something with Brew and you can type some commands on a command line, very simple command line, and off you go. And we try to make it anti-foot gun. So we really thought about it when we designed this. Let's try to make it so that you got to go out your way to mess yourself up. Try to sort of have the perception here of not the security geek that's kind of deeply entrenched in this. So a lot of people when they run will want local access to the folder. Okay, it's like if it's a coding agent, of course it's going to need write permissions to change files to work with the code and read permissions. And so there's a level of the current working directories required. Such as Node, requires certain access controls be present when it executes within a folder. But we still say, are you aware this is the folder that you're going to grant read and write to, but just in case somebody derps and runs within, I don't know, a root partition or something else outside of where they expect to be. So we've really tried to make it sort of as a foot gun protective as we can, but also it's there for the professionals as well. Those that want to go deep, they absolutely can go deep. The policy files are going to be stuff that's going to be signed and outside of the binary, so people can get in and tinker and change and customize to their needs.
For sure, for sure.
Mm.
Okay, let's talk about why. And this is kind of the inception of this episode. It's things like running MCP servers securely, running agent securely. And I mean, for anyone who doesn't understand, is like what are these things doing? And why are we trying to protect them would be my question. Or I guess protect ourselves from them maybe is a more accurate statement here, right?
Yes. Really good question. And I mean that sincerely. That's not just me saying really good question while I try to think of an answer.
Right.
I guess the key thing, of course, is, the probabilistic nature of these things. They make predictions, but they're unpredictable beasts, effectively, and you can have the same repeated input and the output varies every time, so they have this propensity to go off course. And I think within the security world, we love constraints. We like to nail things down, and we like to kind of allow and deny. It's a very sort of very binary world, effectively. And so these two make a strange couple. Okay, and so AI has this ability to be unpredictable, and it is incredibly intelligent. If intelligence is the right word to use, okay, of course, we know this is a neural network, it's a highly dimensional space, it's vectors, da da da. But when you look at when you look at these operate, it's incredible, really, what they can do. And again, it's a case of, you can really go down the rabbit hole with this. It's really, this kind of fickle thing of trust comes up again, because you've got this thing that seems to have an autonomous nature. So it's like a human, really, and if you think about how we sort of set trust up between ourselves as humans, that's a kind of a fickle thing that changes on a daily basis. It's very much, there's this stuff is very difficult to be binary about, effectively, to sort of have a specific constraint that can be applied. And I might have wafted off from the question a little bit there, but you're saying AI essentially, why is it a security risk? Okay, and I guess I would say because it's an unknown risk or it's an unquantifiable risk. It's not something that we can build an apparatus around because it's always going to have the same repeatable results.
I mean, I think that's a fair point. I would compare it almost to like letting the intern run away and prod. No one would do that. That would be
Sure.
nuts.
Absolutely. Yeah. Very much. Yeah. Like some incredibly intelligent intern.
Yeah.
Will just absolutely mess up, will completely mess up every now and then. Yeah, very much. Yeah.
So why don't you kind of explain to us then, like, what is an agent? What is an MCP server when we're talking about it? And kind of like, what does it mean to try to secure those things? And again, almost keep it's this is so weird. I feel like a lunatic sometimes saying this, but like we're almost protecting ourselves from the software we're running at this point, which feels almost backwards to how we've looked at a lot of security in the past.
Absolutely. Yeah. So, I mean, it pays to look at what is in an agent. Okay. So two components here. You have the code, which some people consider an agent. I would say it's more the model. Okay. And I think a lot of people would agree there. The agent itself it's just typical code. It's REST interfaces, login, all the standard components of an application. And then we have the model. That's really the agent because it's, it is it has agency. It's got autonomy. Okay. And where this interacts with MCP is really interesting. Okay. And there's a bit of history to this. So MCP is a kind of evolution of something that was originally called function calling, which is something that OpenAI came out with. Okay. And they figured that they could get a model to linguistically craft a function call. Okay. And that is essentially what happens. The model is typically fed something like a system prompt where it has examples of these functions that it can call. Okay. And there'll be lots of strong language in there, like you will use JSON and you will do this, and lots of kind of to really try to sort of influence the model to use these functions. So the model will know, right, I've got a function called get weather, and within there I can put London. Okay. And then that will obviously go off to an API, which will reply in a very determined way. And then the code will strip and parse that and then feed the result back to the model. And then the model will go, well, it's a little bit cold in London today. Okay. And that's essentially how it works. So it's kind of like, I almost imagine like, those brains that you'd get in the vat with the kind of, like the wires in. It's kind of like giving it some arms to the outside environment. It can actually interact outside of itself, And so you have this kind of this sort of crossover plane of using language, which is passed out into a function. Okay, so OpenAI kicked it off, and it's called function calling. And then somewhere along the line, we started calling them tools. Okay, so they became tools. And then tools became MCP. And MCP is really where there was a specification that was built. It was designed as a protocol by Anthropic. We started to standardize, use the same components. People could benefit from repeated work, and as we see quite often with software. Prior to that, it was a little bit of a Wild West. Everybody was doing it their own way. And, there's many security aspects to MCP. I think a key one is, and we both come from this world, software supply chain.
Yeah.
So, of course, this is software. A lot of it's built on open source, okay? And there's a package ecosystem. A lot of it is, I'm going to tread carefully here, JavaScript, TypeScript, okay? And NPM has had its own fair share of software supply chain attacks, which, I'm sure they would agree with me. And there's a lot of other components that we've not really addressed around security with MCP servers, okay? And agents in general, because they rely on, again, this language to drive computationally the outcome that you want. So the model is able to kind of, craft these words, characters, okay, to interface with an API somewhere. And this is really problematic because of something called prompt injections. Okay.
Yes.
And this is where it gets interesting. So, a prompt injection is effectively where you manage to sneak in instructions to the model that effectively circumnavigate the guardrails that are trained into the model. So models are heavily trained on certain things you do not do. This is some stuff that we've been doing recently. And so, if it's harmful content, the model will push back. If it's clearly a vulnerability, it's a security breach, it will push back. And so people find these ways of crafting these prompts that effectively bypass that system. And, with prompt injections, it gets really interesting because, this is where we start to get to a fundamental problem that we have with the architecture of large language models. We're talking the transformers architecture, which is what drives a lot of large language models. And, at present, there is so we've always had, we're used to having like a control plane and a data plane. Okay.
Yep.
You keep the two separate. Controls is where your instructions are. Data, of course, is where your data is. Okay. And with a large language model, they're all mashed into one. It's all one lump of data and instructions. So you'll load in the spreadsheet or the code, and then the instructions will go in there. And that's where these prompt injections are incredibly different to solve. I don't think we ever really will solve them. We really won't. And I think like an interesting little comparison point to this kind of a hypothesis of the control and the data plane being mixed together. Do you remember the old Captain Crunch whistle?
Yep, that's right.
Yeah. Okay.
2600
Yeah.
hertz.
Yeah. Yeah. So if anybody's wondering what I'm talking about, we're old guys here, so we're old school Gen X hackers. So there was Captain Crunch. It's a cereal, I believe. Was it a popular cereal in the
Oh yeah,
US?
it still
Yeah,
is. It's
it still
awesome.
is. There you go. And they had these little plastic whistles that you could kind of dig out. It'd be mixed in with the food, wouldn't it? You kind of pull out a
Yep.
little plastic whistle. And somebody, was it Kevin? No, who was the?
Well, so John Draper was the one who became the
That's
most
right.
famous, but that guy,
Yeah,
like, don't hang
yeah,
out with
yeah.
him, we'll say.
Yeah. So he figured out that what you could do is like on the old fixed line, you could use the whistle to uh, practically emit the frequencies that were the same frequencies that were used by the control system. Okay.
Yeah.
So I guess these old signaling networks, there's no authentication built into them, stuff like SS7. And so, you could whistle a certain set of frequencies and then you'd get a free international call, I believe, or I can't remember what some of the exploits were. Do you remember yourself?
So, I mean, I I know more about this than I probably should, but
Okay.
so the whistle had like two holes in it. It emitted two tones, and if you covered one of them up, it would emit 2600 hertz, which there's like the 2600 magazine, that crew in New York.
Hmm.
That's where they get their name from. And what happened was
Oh,
on the old networks, the 2600 hertz was like the signal that the phone company would send down the line. They basically said, "Hey, I'm the phone company. I'm going to send you some instructions." And that's where then you'd use, like the blue box to send, because there's certain tones from touch tone that aren't on a normal phone, but would be on a blue box. And then you could create the various instructions for the phone signaling equipment that said, like, route my call this way, dial this person in this way, kind of whatever. And yes, this is exactly the right thing, where the solution to this was to take the control off of the signal network,
yeah.
because the freakers were just like ravaging the phone system. They knew more about it than, AT&T did at the time. And AT&T's security was functionally hoping no one would ever figure this out, which didn't last.
Crazy. I don't want to go off and divert too much into the kind of go into that into the brush, but I used to work in telco security, SS7 networks,
Nice.
and we had these problems with same thing again. You used to be able to key in codes to get like your IMEI, your international equipment identifier, like a serial number, and you could change plans. And somebody worked out that this SS7 network was wide open. There was no authentication, so you could just buy like a modem, plug into it, and start changing yourself onto a business package with unlimited calls and stuff like this. And so kind of coming back to where we were. This is a problem that we have large language models, and there really is no way of stripping out the control aspect of this. There really isn't. That is just a key intrinsic part of the architecture. So we now have this system where there is a kind of a rife exploit, and like I say, one that will never really truly be solved. And I think people are just starting to grapple with this. Some are more ahead of it than others. I think the security industry, what I've seen is that they are having to catch up very quickly with the problems that are there. I think quite a lot of people are trying to fight with weapons from the old war that no longer work in the new war. You see, we've always had this approach of endpoint protection and trust boundaries, and that's always how we've done things. And this is a very different perpendicular world. It's it's a different war that's being fought now. And my own personal views is a lot of the model really protections need to be in the model. Really, that is the aspect that needs to be induced to behave in a certain way that it's not so prone to these attacks effectively. There is, of course, layered defenses that can be put into place. There's this is very much a defense in depth strategy, which is something that we've had in security for quite a while. But I don't think it's as simple as just kind of filtering and grepping and checking for certain strings, because they're never going to be the same. And it's very complex as well, because you've got these chains, reasoning chains. where you can, the people that are performing these advanced prompt engineering attacks, prompt injections, they're doing they're cascading these over multiple conversations. It's really difficult stuff to defend against. And so kind of bringing this back to MCP, really, that is the problem, is you've got this channel that's there to exploit. Okay, it's kind of like social engineering to a degree against
Yeah.
a large language model, and that is really the kind of, I don't want to say the Achilles heel, because we're making some really good progress, but I would say that's one of the key other aspects. So we've got the software supply chain, which we've always had. That's always been problematic, as you know. And then we've got this new sort of component which is susceptible to social engineering, alongside the humans. And I think there are some other aspects, but I'd say those are the two key aspects, really. Is you have this model. Models do, I don't know, they just seem to be a little bit foot gunny around leaking secrets and grabbing everything. They like context. They love lots of context models. So that gimme. So anything is fair game that I can get my hands on to understand the environment better. And so a lot of the time that is keys, little .m files with database passwords, all of these sorts of things are scooped up. And that, of course, that is a very, very significantly large security risk. It really is,
Yeah.
Yeah.
I mean, so, okay, I have an adjacent question then, and this is specifically around like MCP and agents. This feels to me like with a tool like you've written, Nono, is one of the things we need to do is make sure we understand like what an MCP server is supposed to be doing, and then restricting it as much as we can into that context. Like an example being, if I have an MCP server whose job is, say, reading files off of a file system, and now one of the other challenges, though, I think, is a lot of these MCP servers have very kitchen sink-like functionality. So I might need to, say, read files somewhere, but it can also delete files, right? Where this is like, I know what I need it to do, and so I'm going to make sure it can't delete. But then also, once it tries to delete, I know it's gone off the rails. So it's time to go shoot things in the head because I know bad things are afoot. And that's kind of this feels like maybe some traditional security angles that I think are being hand waved away quite often. Because, you mentioned YOLO security, especially like OpenClaw is a great example where people have reported to the Claw, their repo. I can't remember the name of it now. But like there's hundreds and hundreds of malicious plugins, and the owners were like, "Oh, this is hard to fix, so we just don't care," right? Like,
Yeah, very much. Yeah,
wild.
Yeah, very much. And I think you nailed it there, really, which is that and I don't want to apply this statement to everybody. Okay, there are people that build incredibly good MCP servers. They're aware of coding, secure coding, best practices, least privilege, all of these sorts of things. And they're people that have been engineering for years. But there's a lot of stuff out there that has just been whipped up in a day and put out there and been massively popular. Because, well, hey, look what it does. It can do somersaults and it can jiggle around with your calendar and your email and everybody loves a productivity boost, but these things are put out very quickly. They are wide open, really. There is no restriction. There is no least privilege baked in. There's no good practices that are baked in. Stuff that we're, trying to get going in like Open Source Security Foundation and, various bodies been trying to get people to produce better code, more secure code. And a lot of the time, the stuff is just being generated from a prompt. So somebody will have an idea. I mean, that is the thing. You can go from idea to working project in an hour, 30 minutes, even if you don't really know how to code much. So people have ideas, and they'll think, well, wow, why don't we get like an MCP server to, connect to this system and then connect to this system and then bridge the two. And they're kind of thinking of the end result, the kind of, the payload. the productivity boost that everybody's going to get, and it's going to go viral, and they can just, come up with a couple of sentences and bang, it's spat out, and it's on GitHub, and it's got bazillions of stars, and everybody's using it, and so it's just a different world now, really. It's everyone's a software engineer. Like we were saying earlier, I can't remember if this was actually on the podcast. It was me and you chit-chatting before, but Mrs. Hinds, I'm sure I could get her to vibe code up a few apps like an MCP server. It really is that easy now. That is the thing. And then you touched upon skills. Okay. And this I find incredible as well. I mean, if a few years back, me and you'd sat down and somebody had come back from the future, like a Marty McFly or something like that for software security, and gone, markdown files. My God, markdown. We would be like, what? Like just good old wholesome markdown? What do you mean? Where's a security risk? What? People are using markdown to drive application logic. It just, do you see what I mean? And so it's a strange new world. It really is. And so essentially with MCP, again, another great point there. So we got of course, the model and its propensity to be creative, can't be constrained. We've got the good old supply chain, which still isn't really fixed. And then we've got this sort of, people building stuff that haven't really got that prior art in how to build it securely. And lots of people using it that haven't really got the experience in how to secure it, essentially how to do things the secure way, really. So I guess it's a concoction of many different things. And it normally is that, isn't it? It's never typically one thing. It's a kind of a mix coming together that creates the lethal bomb.
Okay, you know what you just reminded me of, Luke, in your description of all of these things is, I'm sure you remember this, but back in the early 2000s, PHP got very popular, and it opened web development to a class of people that could not create kind of anything on the internet prior to that point. Now, I remember as a security person back then, we laughed at them and we didn't help them. And they just kept developing software, and it was awful, and it was full of security bugs. I remember Steve Christie, who was one of the early CVE people, he created the project. He had a joke, he would call it PHP Gulf, where anyone who wanted to find a CVE, just pick any PHP application, and you're 100% guaranteed to find security vulnerabilities in it. And they were full of cross-site scripting and who knows what else. This feels similar to me. And at the same time, I see a lot of security people laughing at these people instead of trying to help them.
Absolutely.
And history repeats itself, man.
Yeah, absolutely. Yeah, you've nailed it there. And I mean, we are seeing that. I mean, I see, we both, I know, frequent LinkedIn a little bit. And there is lots of people that are just scoffing and horroring over these amateurs in their open claw and, and we're not helping them. We're not helping them. And not to try and paint myself as an angel, but I've been over in their Discord channel, the security channel. They got one on OpenClaw. It's there, folks. Go and join it. And it's kind of calmed down a little bit. But over the weekend, that was like an accident ward on a kind of inner city hospital. It was carnage. It really was. There were people just turning up, like it's just leaked my entire life onto the internet. It's just, and there's definitely, I'm with you. This is really not about the kind of smug superiority of being who we are. It's really about kind of chop the wood and carry the water and help these people. Do you see what I mean? Or do we want people to fail because it justifies our existence? Maybe it's that.
Well, it's a little funny sometimes.
It is that as well, of course. Yeah, absolutely. Yeah. I mean, everybody's sort of, it's people falling over isn't funny, but people falling over is funny, really,
Right. But at the same time, our smug, terrible attitudes. I mean, this is something I talk about all the time. It's like, I feel like I tell people when I work with them at work and things like that, and I try to help them with security things.
Sure.
Like, I am paying for the sins of my past. I was a smug, terrible security person. And so I've reached a point, I tell people I work with, I don't care what you do. Like if you paste passwords into web forms, whatever, like come talk to me. I'm not going to yell at you. I'm going to help you solve your problem. It doesn't matter how
Yeah.
dumb you might think it is. Like it is important, and it's hard. That's how you have to build trust. If you're just some smug jerk, people hate you and they're just not going to talk to you.
Absolutely, yeah, absolutely. You know, and security people can have that persona quite often. Maybe not intentionally. Maybe it's just you become, you know, through the attrition of the work, you just become, you know, a malcontent, you know, and and anybody new and shiny that turns up, you just want to bring them down a peg or two, you know. Maybe there's another of that, but yet there is that sort of that persona, you know. I always just remember you know, comic book guy on Simpsons, the one with the
Yeah.
military. Well, actually, you know, that kind of sort of smugness, you know, and I'm with you, you know, it's we're meant to be there to help people, to protect people. We're meant to be the kind of, you know, the guardians, you know, the kind of the people looking out for people. Absolutely. Yeah, yeah.
Yeah.
Mm,
All right, Luke, we come to the end, man. So let's land this plane. I'm going to give you the last
yeah.
word. Tell people anything you might want them to go check out or get involved with or care about, or kind of the floor is yours, man.
Absolutely. So if you check out Nono, it's very early in. Okay, there will be bugs. We have a disclaimer around that, but we're polishing things up. So nono.sh. If you'd like to learn a bit more about the company, follow what we're doing. It's always further. We're doing lots of stuff around open source as always. You know, we've got like a project called Deep Fabric, which is getting quite popular, which generates lots and lots of data that we use for agent evaluations and model testing. And I am typically known as Decode Bytes on sort of different social platforms, and I like to think I'm approachable. You know, I love speaking to people of, you know, contrary to what we were just talking about. I do love speaking to people of all sorts of levels, especially new people. You know, and just it's been really enjoyable. It's gone so quick, you know, because we've been having such a great time. So I really appreciate you having me on, Josh.
Awesome. Yes.
Yeah,
Until next time, my friend, I'm sure you'll
yeah,
be back. Thank
yeah.
you so much.
Take care. Thank you.